in this diagram, line segment CD, so this one right here, is the perpendicular bisector of line segment AB. Okay, so I already have the perpendicular mark right here, so I can also mark those line segments as being bisected. Assume the conjecture that the set of points equidistant from A and B is the perpendicular bisector of AB is true. Select all statements that must be true. Okay, so if this is a perpendicular bisector, and that means that every point on this line is the same distance away from A and B at the same time, that means point M right here in the middle is the same distance away from A and B at the same time. So that would make this a true statement. CM equals DM. Okay, so CM equals DM. We have no idea whether that's a true statement or not, because C could be farther away than D is. And just by comparing distances with our compass real fast, we could check and see if in this particular case it's true. We could set our compass to the length of CM, and if we put our center at D, we can actually see it doesn't, it looks like it does fit right on there. But we don't know for sure that that must be true. It might be in this particular case, but we don't know for sure that AB is the bisector of CD. So we would say that this does not have to be true. EA equals EM. Well, if I make circle E through A, or actually if I just use I guess I could just use my compass to compare these distances, right? If I put A right here, if I compare right here, it looks like they are the same distance away, but we don't know for sure that that has to be true unless we know for sure that that we have a center right here. Okay, so E could be anywhere over on this side. In this particular case, it looks like it was true, but it doesn't have to be true. Okay, because E could have been over here or over here. So the fact that it's on this side of the perpendicular bisector means that basically it would have had to be like exactly halfway in between, but we don't know for sure exactly where point E is. So we'd say this one doesn't have to be true. EA is less than EB. This one for sure has to be true because E is over on this side of the perpendicular bisector and B is all the way over here. Okay, so this distance for sure, like B is on the outside of the circle that we could make here. That for sure has to be true. AM is less than AB. Oh yeah, that for sure has to be true because AM is the distance from this point to the midpoint, and then AB is this whole line segment. That for sure has to be true. Then AM is greater than BM. That for sure cannot be true, right? Because like we had up here earlier, this was a true statement. These two line segments have the same length. So that means they cannot have different lengths, right? So our only true statements should have been A, D, and E. These other statements could be true in this particular case, but we don't know for sure that they have to be true because we don't know for sure like exactly where point E is or where C and D are.